Section 6.3, Logarithmic Functions. In this section, we'll convert from logs to exponentials, exponentials back to logs. We'll evaluate logs, and we'll talk about common logs and natural logs. So this is Section 6.3's Part 1 video. So we're going to write this equation in exponential form. It's log, all right? So I put the conversion over here, but I want to kind of show you how I do mine, and some things you got to keep in account and understand. The base of the log and the base of the exponential have to be the same. So the base of this log is y, so y, and then we're going to do what's called a backward C. Y raised to the p equals w. That's a w. So that's how you do it. You convert it. You use backward C. And we can do that with exponentials back to logs. The bases have to be the same. That's what you have to understand. Okay? And if you do that and do the backward C, you don't have to worry about memorizing that little chart. All right, so we're going to take a bunch of logs and we're going to rewrite them into exponential form. So the base ought to be 7 raised to the negative 2 equals 1 over 49. This one is a log with no base. It's called a common log. Is a log with no base. It actually has a base. The base is understood to be 10. Okay, so the base, anytime you see a log by itself, it's called a common log, and there's a 10 here. So you just go ahead and write 10. So base of the log is 10, so the base exponential is 10. That's raised to the x equals 152. All right, now here's where it gets it gets easy, but you just got to make sure that you are doing this. The natural log of x is nothing more than a log to a base of e. All right, so these two things are the same. So what I'm going to do is I'm going to rewrite the natural log of x as log base e of x equals 3. Now, what that allows me to do is say, okay, the base of the log is e. So I'm going to do my backward C equals x. So anytime you see a natural log, rewrite it as log base e, and then you can convert it much easier. Okay? All right. Now we're going to convert exponentials into logs. It's not that hard. Here's the base exponential, so therefore the log has to be a base of 6. Now, there you go. Log base 6 of t is equal to c. It's kind of messing up on me there. There you go. All right. So pretty standard there. So again, always remember, log of the base and log of the exponential, when you convert them, have to be the same. So if you start there, it's just a backward C. All right, so now we got a bunch of them we got to convert, right? So this is going to be log base 2 of 32 is equal to 5. So if you kind of look at this one kind of makes sense. The exponential is 2 to the 5th is equal to 32. Well, the log and exponential are inverses of one another, okay? So the way it's written in a log, it's saying log base 2 of 32 is equal to 5. So it's basically, when the base is 2, what does it need to be raised to get to 32? That's the answer for the log. So it's the exponent of the exponential, which is your answer for the log, okay? So if that made sense, you'll be good. If it doesn't, then we will revisit that later. So this one has log base 3 of 9 is equal to 2, right? What does 3 have to be raised to get 9? 2. All right, so we've got log base 10 of 100,000 is equal to 5, and we'll rewrite it as just a common log, right? There we go. And because of that, you know, if you have a log base 10 of 10, 100,000, 100,000, so it's just counting the zeros, right? What does 10 have to be raised to give you that, right? And then, of course, let's do this. I always like to write the exponential first, right? That just allows me to do it a lot easier. So, again, we got a common log, right, of boom, 0.0001 is equal to -4, and of course we need to write that as just because it's a base of 10, just a log of 0.0001 is equal to -4, right? Okay, so that's converting exponentials into logs. All right, so what we're going to look at next is kind of simplifying and solving expressions, right? So the first thing that you need to know to solve a log is you need to convert it back to an exponential. So 3m equals 729, because I've done this, right? The base of the log was 3, the base of the exponential is 729. Now, there's a property that says, hey, if I can get my bases to be the same, then I can set their exponents equal to one another. And 729 actually is 3 to the 6th power, so therefore m equals 6. Okay, so we're always rewriting. We're bringing things down. We're never bringing them up, right? It's this, then that, right? So let's do this one. The base of the log is 4, so the base of the exponential is 4. Raised to the 4th power equals m, so m equals, well, that's 256. So sometimes they come out like that. But you're mostly rewriting stuff, right? So let's look at the next one. So I don't think there's another one, no. There may be on your homework. It says find the log without using the calculator. All right, so this is really a 10 down here, right? And this is going to be an unknown. So 10 raised to x is equal to 10,000. Now, I can rewrite 10,000 as 10, count my zeros, to the 4th, right? So x equals, guess what? 4. And there you go. So 4 is the answer. So this concludes part 1 of section 3, logarithmic functions.